afternoon, everybody. Welcome to class this afternoon. Thank you for joining me, whether you are watching live or you're watching the recording later on. I really appreciate you just watching and being a part and taking part in your education. Really means a lot to me, and hopefully these live classes and such mean a lot to you, right? Hopefully you're getting something out of them. Today we're going to start talking about Git, right? Because Git is module 2, so Git... the Git module will technically start tomorrow. Remember, as always, for these live classes, we talk about the material for the next module, the things that we're going to be doing next. So you can have, an entire week to review the material, go back and read everything, go back and watch everything. Right, and, get involved and get things done. Before we talk about Git in particular, we got a lot of demo and stuff to do today with Git. I just want to give you a couple of announcements. One, don't forget your boot camp website assignment is due today. It's due this evening by 11:59 p.m. So you want to make sure you'll get that done. As I mentioned previously, one of the things I do, if you all have turned your assignments in early, I wait and I get everything in and grade it together after the due date. Right, that way everybody's just kind of being graded on a level playing field. Everybody's had the same amount of time to get things in and all that sort of stuff. So, you get the opportunity and you get the time. And I know during the summer things go a little bit faster and our lives are different in general. And I know some people might want to try to get ahead and get things done early, and that's fine with me, right? I don't worry about when exactly you want to try to get things done. I have the course kind of built in an order that I think would be helpful in terms of being able to, kind of go through the material and work with things and do all that sort of fun stuff. But, like maybe you want to go on vacation in a couple of weeks and you want to get ahead now so you don't have to worry about class in a couple of weeks or whatever, right? And that's fine by me. So, but just remember that if you do that, I won't necessarily grade your assignment right away. I wait until the due date to grade assignments, and then I'll get them graded within 7 days of the due date. So there is that. Let's see here. Module 1 due tonight. Talked about grading. Check my list, see if there's any other announcements. If you have any questions or you think of anything while you are just working on stuff or watching this video, again, feel free to send me an email, send me a Teams message, whatever you'd like to do. Don't forget, all my information is right there in that Begin Here module in the course. So let's get to talking about Git, shall we? We'll talk about Git today. And Git is a tool that seems kind of daunting, right? But in the development world, basically everybody uses it nowadays. They either use Git with GitHub or Git with a private Git repository that they have access to at that organization. So being able to use Git and being able to send code and pull code and all this kind of stuff from Git is super important. So today we're going to talk about what Git is, maybe a little bit of the history of Git, what Git is, how Git works, and we'll do a lot of demonstration today to try to get us to where we would want to be for, our assignments and stuff this week. And when we hear the word Git, a lot of us might be familiar with the word Git in a different context, right? Like, being from the southern United States, you've probably heard the word Git a lot. And, this was funnier a couple years ago when it was more relevant. Right? I talked about shaking their Git stick at the Sasquatch when that was in the local news around these parts. But, we are the Yetis, with that being said. So, this is one of those things where the Git stick won't keep us away, even though we're Yetis. Because we're going to use Git to help us collaborate on our programming, on our code bases, and with our programs and with our websites that we'll be using. So if it's not like a Git stick, if it's not something that, wants to send us away, what exactly is it? Well, it's something that kind of wants to bring us all together, right? We said it's our big collaboration tool that we're going to be utilizing for the semester. And it's a version control system. And another term that we could use for that is a source control management system, or SCM system. And Git isn't the only source control management system or version control system that exists, but it is one of the most widely used ones. It can be used locally on your machine, or it can also be used on a server, right? And so we can have local Git repositories and we can have remote Git repositories. And we'll see that as we kind of do our demonstrations today, right? Like as you're developing, you're not necessarily developing on a server environment. You're developing on your local machine. And so I'm writing .html files, .css files, .js files, .py files, .java files, whatever coding language I'm coding in, I'm writing them on my machine. And then I want to be able to push those to a location where other people who are working with me have the same access to the same files, or I can kind of keep my versions separate, right? Because, that's one of the things that we have issues with a lot in programming, right? We work a lot on some code and we have it working and then it's good. And then we make some changes to it and then all of a sudden it breaks, right? Or we make some changes to it and, maybe we accidentally delete everything, right? So having a versioning system is going to help us with that as well. And then we can also, use our remote server to share it with other people, collaborate, all that kind of fun stuff. So what we end up with here is what we would call a distributed architecture, right? Every single developer, every single person that's working on the same code base has a repository that contains a full history of all of the changes, of everything that's been done, of all of the work. So everybody has their own complete copy. And we'll be talking more about what that means here in just a little bit. Because, one of the questions that you might be wondering about is, well, why would we even use a version control system, right? Why would we even use a version control system? And we kind of mentioned that on the last slide here, right? The fact that code is an iterative process. We write a little bit of code, we test it, we see if it works. We write a little more code, we test it, we see if it works, we see if it's what we want. And so maybe the first block of code we wrote, it works. It's great. We'll commit that. We'll save it. And we'll create a version out of that. Second block, maybe it works as well. And everything's great. And so we can commit that. We can save a version that has that code in it. So now we have one working version that has some code in it, a more updated working version that has some code in it, right? And we have these two separate items that are in our history that, maybe if we get to the third, we make some changes and all of a sudden they break everything. Then we get this Super Saiyan Control Z that allows us to go back to the last working version that we committed. So, any of the mistakes that we made, any of the big time issues that we caused that would result in us, losing our code, missing or messing our code up, it's all been wiped out. We can kind of start anew. So you can make mistakes without worrying that you'll have to just start over from scratch, right? And I know that's one of our biggest fears, right? Is the fact that, I could be working on something, I could be working on it for hours and hours and hours and hours. Some of you who have taken, more programming classes realize that, if I work on this one thing, I could be working on it for 30 minutes, an hour, 2 hours, 5 hours, however long it takes me to get it done. Right? One of my biggest fears would be, being 3 hours into a project, 5 hours into a project, having hundreds of lines of code, and then all of a sudden making a mistake that breaks everything, or accidentally deleting everything, or just something that causes me some issues that results in my code not working anymore. And it's, oh no, I have to completely start over. I have to start over from scratch because I broke everything. Or I accidentally deleted everything or whatever. We don't want that, right? So we use a version control system to allow us to do that. And that's why Git exists. That's kind of the precipice, the initial founding thing that, we got this idea to kind of create Git and utilize a version control system for. And then the collaboration piece was also a huge part of that as well. Speaking of, kind of what Git was originally for, that brings up kind of the creation of Git, right? And Git's actually not that old. When we think about things like Linux and we think about things like, different code bases, like, Python came about in like 1991, right? Java was around that same time. C++ and different programming languages were earlier than that. Linux, the operating system, was earlier than that. Windows operating system was earlier. Right, we're on into the 21st century here with the creation of Git. So people had been coding for decades before Git came to be. Right, and now we don't necessarily know what we would do without it. That sort of thing, right? Because, of all that version control importance and collaboration importance that I've mentioned, that we'll get a little bit deeper into here in a few minutes. But it was created by Linus Torvalds, who was also the individual who created Linux. So when it comes to a lot of modern computing and a lot of modern programming, Linus Torvalds is really a hugely significant figure, right? Considering that many developers also, develop on Linux, and they're all using Git, right? Like the fact that a lot of people can work at all is kind of completely owed to Linus Torvalds. And the need for Git came out of the Linux development community, right? Because Linux is an open source operating system. And by nature, when something's open source, in order for something that is open source, especially that is as large of a code base as the Linux kernel is, you need help. Right? So it's open source, so you're providing it for free, so anybody can get it and download it and use it for free. So you're not making any money off of it, so you can't really pay anybody off of it. So, but you have this massive project, you need people to help you, right? And if you have a dedicated community, like Linux does, they can come in and they can help and they can make changes and they can make updates. They can fix things. They can improve efficiencies. They can do all this kind of fun stuff, right? But the issue then becomes, well, if I've got 5, 10, 15, 20, 50, 100, however many people working on this particular set of code, this particular huge code base that belongs to the Linux kernel, how can I manage that? How can I utilize a version control system that would be able to accommodate dozens, if not hundreds, if not thousands of people? So the creation of Git really came out of necessity, like most things do, right? Like we see a need, we have a need, we fill that need. So all of these people who are contributing to the Linux kernel being able to, provide code to that code base so it can remain operational and remain a living project. Git really facilitated the ease of use to be able to get people continuing to work on said projects. So we kind of know the gist of Git now, right? Like we kind of have this idea that, Okay, Git's a version control system. It allows multiple people to work on the same project by giving everybody their own version of the project that they can work on and then make changes to and commit those changes and send them kind of back and forth into a ledger to where it's kind of, you have all these different versions saved and kept. But how exactly does that work? And so in Git, you don't check out from a central repo. You clone it and you pull changes from the clone. And we'll practice all of this in a little bit. Right? Your local repo is a complete copy of everything that's on the remote server. Right? So we're using GitHub for our remote server. And so we'll do an example of this in a little bit. I'll have an example where I create and upload some code from scratch. And I'll have an example where I take somebody else's repo and I fork it, because that's what you'll need to do to be able to work on your group project. Is you'll have to take whoever your group leader is, you'll have to take their repo, you'll have to fork it, you'll have to clone it and pull it down and then send changes back to it. So your local repo is a complete copy of everything that's on the remote server, and your copy is just as good as anyone else's who is working on that project. Which is significant, right? Prior to this point, the way that a lot of things worked, right, is if you wanted to work on a document or work on a piece of code, you had to check that code out. Right? And there's a service here at the college that still works in a similar way, right? If you are, it's the information that the system that keeps our student data works in that sort of way where you have to check a student's information out, right? So if I want to update or edit or change a student's information, when I get into that student's information, I've locked it out from anybody else being able to do any work on it. And so when we say check out code or check documents out from a central repo, that's kind of what we're talking about, right? So we check it out like a book at the library, then we have it and nobody else can have it and work with it. So until we do what we need to do with it and send it back, nobody else that's working on the project can have anything to do with it. But with Git, that's not the case, right? With Git, we get our own copy. So probably the library aspect of it would be the most relevant, right? Like, let's say if there's one book in the library that you needed to be able to complete an assignment, and somebody else had it, you'd have to wait until they give it back for you to be able to use it. If there were enough copies of the book for everybody to have one, then you can just do your work on your own. And then everybody turns their work in and somebody grades them and says, what's good and what's not. That's kind of what we're dealing with here. And so most of the operations that you're going to be doing are local. They're going to be operations that are going to be done on your machine. Checking things in and out from the local repo, committing changes to your local repo, and, keeping your version history. That's going to be done locally. That's going to be done on your machine. And when you're ready, you can push what you have on your local machine back to the remote server. And so we kind of see a process like this, right? And in this instance here, and we can make this a little bigger so you all can see it just a little bit better. In this instance here, we have two people that are working on a code base. We can see that each person has their own copy of the file. That's what we have in blue here. They have a version database of each of the versions. Everybody has their own version database. right? That is a complete version history that's the same from server to computer A to computer B. Right? Everybody's able to pull all of these versions from every location, but I can still work on my own file, still do my own versions and push my own versions and all of that kind of fun stuff. So it's super, it makes things really easy to work with. Let's talk workflow, right? So typically what we're going to do is we're going to create a project on our computer. Hint, I've already done that, right? I did that a little bit earlier this morning. I'll show you the project that I created here in just a minute. And then we're going to tell our version control system to track the changes that we're going to make in that project. So we're going to tell Git to initialize itself in order to be able to track changes in that project. And so each time your project is in a working state, or you're going to walk away from it, you're going to tell that version control system to save it as the next version. Right? Easy peasy. It's way easier than it seems. And so then if you need to add a new version, or you need to go back to a previous version, you can tell your system to go back. To a different version. Which is pretty cool, right? And it's really easy. Like, it's a lot easier than it looks. So we'll go back to we'll revisit our slides here in just a few minutes. But I want to go through and I want to talk about the project that we have here. So I've built this project. I built it this morning, built it really quickly, right? Just because I wanted us to have a project that doesn't exist yet in my GitHub that we can kind of work with here. So I have this Git cheat sheet that I've created. It's just simple HTML, CSS. If we go into my Visual Studio here, you can see the code where I've written it. There's my HTML file. There's my CSS file. And of course, we're getting ready to put this on GitHub here in a little bit. So you'll have access to all this code to see it a little more closely. But today isn't so much about the code as it is about the versioning. Right? So I've already installed Git for Windows on my computer. If we go into our course, we can see that here in our module 2, here we have that you're to download and install Git for Windows or for whatever device you're using, right? It's available for Mac, it's available for Linux. So I've already installed Git for Windows. Right there we see that SCM that we talked about just a minute ago, the right, and it gives you the Git bash, which is what we're going to be using, and the Git GUI, and it also integrates it into your shell, so you can take advantage of things from Windows Explorer, like I'm about to show you, which is pretty cool. So before you do any of this, one of the first things that you'll want to do is download and install Git for Windows, right? Which is right here in your instructions. You should be doing that. And so you'll have your project, you'll have your project file. Your project file will have your code in it. Here's my project file. So this, if we go back to last week when we went back to the boot camp, I created this project file in exactly the same way I created my bootcamp project file last week. I created my folder using Windows Explorer. I went into Visual Studio Code. I opened up that folder. I added my HTML and CSS files this way. And now I have them on this folder and they're ready to go. Right, so one of the great things here is that since I have Git for Windows already installed, I can just navigate to my folder in Explorer. I can right-click in my Explorer window, and you'll see I have two things here, Git GUI here and Git Bash here. So instead of having to, open up my command prompt and navigate using commands to this folder, I can just, navigate to the folder with the GUI using Explorer, and I'm going to select Git Bash here. And that's going to give me a special Git command window here, a special Git Bash interface that will allow me to enter my Git commands. And so the first thing that we said that we wanted to do was, well, if we go back to our basic Git workflow, right? Create a project, typically a folder on your computer. We've done that. Now we need to tell our version control system of choice, which in this case it's Git, to track the changes. So in our Git Bash window, let's go ahead and make sure we have everything up here. In our Git Bash window, I'm going to initialize Git. And we'll see some changes happen in this folder when I initialize Git. So basically all of my Git commands start with the keyword Git. So we're going to type in the keyword Git, and we can try to zoom into this a little bit so you all can see this a little bit better. So we'll start out with our keyword Git, and then we will initialize Git in this folder by adding Git init or Git initialize. Right, and that's going to initialize Git in this folder. It's going to tell it to start listening for changes to occur to the files that are in this folder, or to what we have in this folder. And so now it's initialized an empty Git repository. And if we go back to our project folder here, we can see that we have a .git file here in our project. It is a hidden folder. So if you don't have show hidden folders turned on in your Windows Explorer, you might not see this folder. But we can go in there and we can see like all the different pieces of information that we have in here. So now, essentially, all we've done here is in this Git demo folder that we have here, we've just put a little bug in there where it's our Git, and we're telling it to listen to stuff. We're telling it to listen to changes. Now, something else that you could look at here is that also what happened when I did that is Visual Studio changed. And this is pretty cool as well, and we'll go have a look at this in a little bit. We see that we have use here, and our titles are green. This means that everything's been saved, but it's currently unstaged. Right, so what we need to do is we need to stage these files to be able to make a version that we're working with. And in order to do that, I use my add command. So this will be git add. And you could add a file name here, right? Like I could add these files individually. I could git add index.html, git add style.css. But what I prefer to do typically is if I'm working in Git and I have Git initialized in a folder, I want all the files that have made changes, that I've had changes made to in that folder, get added to the staging area. So I can do that by simply putting a period here. So git add period. And if we hit that, that's going to take and it's going to add all the files that are in this folder to a staging area that's going to get it ready to make a version. Right? So we have to take after initializing, we only initialize once, right? Because it's got that bug in there. Every time after that, when we're ready to create a new version, we need to add the files that we want to add to this version. In this case, we're adding all of them. And then to actually create the version, we're going to commit it. So it's going to be git commit -m. The -m here means that we want to add a message to our commit. And then we can put something like, since this is the first commit here, we can put that it is the initial commit. And hit enter. And then it tells us everything, right? It tells us everything that we did there. We see we have a location here, right? We have an object in memory location here, CCD 2704. That's our master root directory located in our Git of where this version is. So this is we can think of this as being version CCD 2704. We see we have 2 files that have been changed with 245 insertions. That's all the code for all the files. Create mode 1644 index.html, create mode 100/644 style.css. Those are the 2 files that we've added in there. And so we have a commitment here that's been made. Now, if we go back to Visual Studio, we see those U's go away because they're no longer unstaged. Now they're committed. And if you'll notice here, if yours says author unknown, you might need to go through the process in the module first of setting it up. It's hard for me to show setup, which I probably should have mentioned that there. In your module, adding the information here where you have your user would be the first thing that you need to do before that. Jumped the gun a little bit on that, didn't I? Yeah, sorry about that. Hard for me to show setup when it's already been set up for several years. Sorry about that. Yes, you will want to set up your Git before you use it. And so now in my Visual Studio, I can also do this stuff from Visual Studio. If we look here in our side navigation menu, we see we have this little source control tab here, where we're kind of branching off into 2 separate paths. That's for Git, right? So I can actually click that, and I can actually do this from here as well. Right, which is pretty fun. I can use my terminal to run Git commands from here, just straight from within the project without having to leave Git. I can also use the source control tab here to be able to do that as well. And we can see here, if I use my 3-dot menu here, I can actually get all of pull, push, clone, checkout, fetch, all the commands here. Or I can do it from the terminal in Visual Studio Code as well. So if I went in here and say added a little bit to this code, right? Like one of the things that I might want to do is let you know that, if you're going to use your git add file to stage your files, I might be able to say use code git add period to stage all files in your initialized folder. Right, so now once I've made that change, I can save that change. My source control is going to know I have something that's been changed here. I can click that and it'll show me my differences. I can use this plus here to stage my changes. And then I could enter my added more information, control enter. And now it's been committed as a separate version. All right, so now I have more than one version after we've made that change in there. So that's an example of how we can make changes through our Git bash and just through Visual Studio Code directly. Right? Me personally, I kind of like doing everything with the Git bash. We can do them with either. Right? But one of the things that we can look at now is we can look at the log and see the commit history here. So I can type in git log. And that's showing me 2 commits. Right? We have my CCD 270 commit. Right? CCD 270. CCD 270. And we have the commit that was made by or through Visual Studio Code, which is FCC A9F. Plus some other stuff, right? So we can see these things here. If we were to want to go back and revert to where we were before, we can do that. Right, so all we would have to do here is, since we've used this git log, we can check out this previous commit and we can go look at it from there. Right? So what I would want to do is I would want to git check out and then use the CCD 270. You can put as much of that in there as you want. All it needs really is enough to be able to tell it difference from the other commits that are in the log. So git checkout CCD 270 should be enough. And so now it tells me that I'm in a detached head state. And so I can look around and I can make some experimental changes and I can commit those changes and I can discard any commits that I want to make. And if I want to create a new branch to retain new commits that I make, I can do this switch here. But if we go back to our code, we can see, if we go back to the add, that no longer has that information I added in there. Right? I didn't delete that out. I left that in. But since I checked out the old version, it automatically updated it to be what's present here. And so what I might want to do is undo this and just go back to the one that I had previously. Which I believe I can do that with just the git switch command that it tells us here. Undo this operation with git switch dash. And we saw it automatically update behind us here, right? We saw this to stage all the files in your folder. So this is one of the great reasons why we do this. Yes, like I'm able to take and, make these different commits and make these different versions. I can go back to old versions if I need to and work on something. Right, I can fork this off and create a completely different fork of it, which I'll show that when we get to what we need to do with other projects here in just a minute. But we have this project or process here that basically looks like this, right? Like we've done this local part of the project here. We've done this local part of the project. In our working directory, we did a git add, right? We use that git init to turn the directory into a working directory, or a working git directory, I should say. And so we did git add to stage all the files into the staging area. We did the git commit to put them into the local repo. And then we were able to check out files using git checkout to get back to previous versions. So in terms of working with our local git, that's going to be the vast majority of things that you're ever really going to have to do with your local git. Right? Just every time you make new changes, you're going to git add period. You're going to git commit -m, put a little message in there of the changes that you made so it makes sense to you when you see it. And then if you need to go back and work on an old one, you can use that git log to see the logs of all the commits that you've made, and use git checkout to go backwards and get an old commit that you had done previously, or an old version that you'd done previously. So that leaves us with the remote. Being able to push and pull things to a server. So in order to do that, our remote of choice is GitHub, right? We talked about GitHub. Everybody should have already made them a GitHub account, or should be making one soon. Here's mine. After you log in, it should look something like this. And this is your main GitHub page. From here, you got a lot of different directions you can go. Most of the stuff's going to be up here on the upper right-hand side under your icon. You can see your profile. You can see your repositories, your code spaces, your projects, so on and so forth, right? So I'm going to go straight to my repositories. So that's my icon here and your repositories. And you can see all the code repositories that I have here. So all of these are code repositories that I have created on Git. I have pushed them to GitHub, right? Most of these are just class demonstrations and things of that nature. There are some other stuff here like IT advising. That was a little project I built to try to make a little advising site to help with advising. But as you kind of saw last week with what I sent you all, you can see all the code that you're working with on basically anybody's public GitHub, right? So like, for example, this online readiness thing, it's an online readiness quiz that I built. It's got a dependency in it that has an issue apparently, but that is okay. It's handlebars. It should be fixed. But we can see here all the commits that I've done to it. I have 39 commits that I've pushed and pulled. If I click here on the commits, I can see all the commits that I've made. The message that we have here, this is just the message that you put in after the -m and the get commit -m. It pushes that to the version here. I can go see a specific version and what was changed here on GitHub. And this is also the way that I would see your collaboration, right? Because I can see who pushed the commit, when they pushed the commit, who approved the commit. In this case, they're all me, so I just approved, they all just went straight through. But I can see all that information on everybody's GitHub, so I can see, how many commits you made to the code base and what all you did with it. And so if I wanted to start a new one, if I wanted to create a new one, I have this bright green new button here on my repositories page, and I can just click that to create a new button or to create a new repo. And what I've made for you all here is a Git cheat sheet. And it basically just uses an already existing Git cheat sheet just to put it in website format. I just wanted to have something to be able to push here. So we'll call this SU22 Git cheat sheet. I can give it a description that's optional. By default, public, right? Unless you pay for it, it's going to be a public Git, a public GitHub. So anyone on the internet can see the repository. You can choose who can commit to it, right? We do this through pull requests. Once somebody commits to it, it creates a pull request, and you can just approve it or deny it. And I'll probably, since this is going a little long, I'll probably send you all another video that has a look at that, or maybe we'll try to do that really quickly. And most of this stuff is optional, right? Really the only thing that you need is the owner and the name, and then I can create the repo. And then it's going to tell you everything that you need here. Right? So in this first section here, these are all the commands to be able to get this online. I've already initialized Git. I've already added my first commit. I might want to add it a branch. It gives it a branch by default. So if I wanted to be specific here, I can add this branch. So let's just do that, and let's just follow everything that we've done here. So in my local repo now, I'm just going to add git branch dash uppercase M main, just like it's telling me to do here on GitHub, and hit enter. It's going to create a new branch called main. I can just copy this line. This git remote add origin is just going to add the server repository as a location to be able to send this code, right? So git remote add. From there, we can call it whatever we want, right? We're calling it origin here. We can call it something else, right? Like we can call it git remote add s. That's just giving it a name. Then we paste that link that it gives us to us in there, that github.com/whatever. We hit enter there, and it will add that remote. So now I have a remote named S that points toward this URL. If I used it as written here, I would have a remote named origin that would point toward this URL. So now I want to push to my remote from my branch. So on GitHub here, it says git push -u origin main. on my local repo, I called my remote S. So I would want to push to S. So this would be git push -us main. And it's going to do it. Right? It tells us it enumerated objects. There were 7 of them because of the different commits and different things that we had there. If I go back here now and refresh this page, there's my code. It's right there. And we can see there it all is. It has the full history of my commits here, right? Because just like we said during the slide part, right? We have all the commits. All the commits are saved locally. Everywhere that has a copy of this gets a full version history of all of the commits. So when I pushed this, it pushed all of the local commits with it. And we see we have those commit numbers there as well. CCD 2704, FCC A9F3. Right? We can see the changes that we made. All of that information that we did locally, we just pushed that to the remote server. Easy peasy. And so from here, we can actually make a site, which is pretty cool. That'll be live on the internet. If I go to my settings here, and I go to pages, I can use GitHub Pages to make this a website. So I can use GitHub Pages. I want to put it on the main branch and save it. And I've made myself a website. And it's giving me a URL where it'll appear. And it might not appear right away, right? It's going to take a little bit to enumerate and get online. So while we're waiting on that, let's go look at cloning a repo. So this is a fun practice Git. I'll put the URL for this in the announcement with today's video as well. So you can kind of use this to do some practicing with. This individual, Gray Ghost Visuals, as you can see, they've merged one of my pull requests previously because I've used this same for demonstration before. And this is a really great, like this individual here, this Gray Ghost Visuals, you know, this particular GitHub in particular is about just people learning how to use Git and GitHub specifically. Right, so if you want to practice with this, you can. And you can use this to practice, and you can use this to try to go in here and make changes and do whatever you'd like. And it helps you. What commit did I do here? Let's see if I can remember. I added a link to the README file. So I put something. What did I put in here in the README file? The 19 Git tips for everyday use. I added that. So that one right there at the top there was a site that was added by me, which is pretty cool. So if I want to start working with this one, the first thing, and this is what you would need to do to work with your teams. So let's put a good hard stop here, right? And just make sure this is evident. Your team leader or whoever's taking that primary responsibility role on your group will have their repo, and you will need to do this to be able to get your own repo. So the first thing I'm going to do is I'm going to go up here and I'm going to click. I'm on Gray Ghost Visual, whatever the other repo is. I'm on their repo page. I'm going to fork it. Fork. Now it's going to tell me that I already have a fork of this. Otherwise, it's going to tell you, you can make a fork. Right? Making a fork is super easy. Let me see if I can just click on a fork page for something else here. I was looking at Honkit to make some books and stuff with here. If I click fork, it'll just give me my name plus a repository and a description, create fork. And then what this does is it takes this repository from this page and creates a fork of it on yours. So here's that same practice Git on my GitHub, right? You can tell it's mine because it has my name here. Now it's still forked to Gray Ghost Visuals practice Git. So I can use this and work from this. And it says that I'm 2 commits behind. And so in order to get back up to date, before I do anything else with it, I can fetch upstream, fetch and merge. And that will fetch the entire commit log from Gray Ghost Visuals and get me back up to date. So, that would be important for you all. Like, if some of your classmates were working on the project a lot and you were kind of some commits behind, you'd want to do that. But now from here, I can take this, I can pull all this down. Right, so let me go back here. I'm going to create a new folder. New folder. In my little Web 140 summer folder here. And this is going to be, this is practice Git. And now I'm going to open up my bash here. So I'm just going to right click in this empty window. I'm going to get bash here. And now what I want to do is I want to pull this code down locally. So here in this big green code button, I'm going to find this HTTPS. I'm going to copy that. I'm going to come in here and I'm going to type git pull paste. Oh, I need to init first. Git init. Now I can pull. And so that's going to pull everything down from this fork to my local machine. And so now I can go in here and I can do what I need to do with this, right? So for example, if I wanted to add another link to this, and I should have opened that in Visual Studio instead of double clicking it to open it in brackets, but 6 of one, half a dozen of the other, it's all fine and good. But it looks like it's going to give me that opportunity. Because that's my README. I need readme.md. And this is marked down here, so it's a little bit different. Right, maybe I want to take a... Maybe I want to get the Git and GitHub crash course from Free Code Camp and put that link in here. So let's do that. We'll put it here. We'll call it Free Code Camp. Right, this is just editing code here is all I'm doing. I'm just making a change to this file. And then we can save that. Right, so now I've made a change here. And so if I look at my branches, which would be one thing that I would want to look at here, because I have different branch names here. I have new B, which is the one that I use here. So I want to make sure that I'm checking out new B. And so in order to do that, I can grab that branch. It is new underscore B. And then the things that we were doing before, right? Git, add everything with the period, git commit -m, added free code camp, link to resources in readme.md. Git push new B, or git push origin new B. Or, you know what, I haven't set the remote repository yet. Need to do that. Same way we were doing that before. Git remote add origin at that link, git push origin new B. And so now if I'm on my new B branch, then I go into my README. Well, oh, what have I forgotten here? Yep. Oh, because I added it on. I wasn't on. I was still on the master branch, it was telling me. It didn't actually check out. I needed to check out, get check out, new B. Yeah, that's what I did. Whenever you want to work on a different branch or a different version, you have to check it out first. Git add everything, git commit -m, added free code camp, link to README. Now I can git push origin new B. Everything's up to date. Probably because it's already done on the master. Yeah. Oh yeah, when I checked out new B, it checked out the old file. Yeah. So that's one of the things that, you know, because it's not there anymore here because I checked out the old file. Yeah, you just gotta pay attention to what you're doing. But from here, what I can do is I can take this most recent commit on master, and I can send it back. And in order to do that, I would have to actually go back to the other page, which is here. I'd want to create a pull request, new pull request, and I want to compare across forks. So in the base repository, Gray Ghost Visuals, base master to my master, I made a change. I can create the pull request. I can create the pull request. Leave a little message if I want to. And now that pull request is sitting there for Gray Ghost Visuals to merge if they so choose. Right? If I go back here to the pull request, I can see there is my open pull request waiting for Gray Ghost Visuals to come back and say, cool, this is good. I'm going to merge this pull request. And so that's what your team leader, your group leader, would have to do. Right? You would go in here, you would go back to the original one, you would create a new pull request. You would compare across forks, the main one to yours, and you'd create a pull request from that, and then your group leader would decide, yes, we want to commit this, no, we don't. And then that would get committed to the code base. So there's a ton of stuff here. Obviously, right, like I could talk about this for, all day long. I'm going to include some additional resources, including that free code camp resource that I just added to this practice Git. With the recording of this here, before we go here, let's check to see if our GitHub page has enumerated yet on the internet, and it has. Right, so for all your assignments from here on out, when you publish a website, I want you to create one of these pages and have it link me to it, in addition to having your code in your GitHub. So you'll send me one link of this, one link of this. Also remember that if you use index.html, then it'll just open on the base root site. If you name your file something different, I would also have to include whatever the name of that file is, .html, in the link for me to be able to go there. So since we are at the hour and 10-minute mark, and I've already covered way too much material, I'm going to go ahead and stop here for today. If you have any questions, or you can go ahead and put them in the chat now. If you're watching this later and you have questions, please let me know. Send me an email, send me a Teams message, and we can figure this out. Remember, Module 1 is due tonight by 11:59 p.m. This is due next Thursday by 11:59 p.m. And so with that being said, I'll turn the music back on for a few minutes, hang out in the chat for a couple minutes here just in case anybody has any questions. Thank you for watching, and we'll see you next time.